marking variables with uProperty macros. We can mark variables in our actor with the uProperty macro. This designates them to participate in garbage collection. It also allows us to expose them to blueprints. The uProperty macro can take arguments called specifiers, which determines the various quality of the particular uProperty. We will start by creating a couple of variables. So uProperty, let's go in our first actor in the public. We already explained the float dt, but I'm going to delete that one and use uProperty property and argument visible anywhere. Yeah. Let's one time we do something here. Let's first debug that. Let's what's going on. Visible anywhere. View property visible. Okay, that's correct. So sometimes it's take a time to recognize the macros, I guess. So and view properties and float actor lifetime. Okay, the actor lifetime. This should be float actor lifetime. So this is uProperty visible anywhere and float actor lifetime. So this is our variable. And next, another uProperty. Like now, bring it automatically and do edit anywhere. Edit okay, and int actor level and come. So notice that we don't place semicolon and at the end of the lines with uProperty. So we don't putting the semicolon here, and but we putting the semicolon end of the floats. Our first variable actor lifetime we designate to visible anywhere, which means that we can see property on the blueprint once we create it in the details panel, as well as in the detail panel for the individual instance of the actor in the game. The second variable actor level we designate to edit anywhere, which means we cannot see in the value in the detail panel for blueprint as well as in the detail panel for an instance of the game, but we can change it from details panel as well. So let's compile it and see what's going on. Before compiling, let's go here and put in our tick. I'm going to delete those. Let I comment that first and okay, nice. And let's see, actor lifetime we added up there, that automatically recognizing plus delta time. Okay, and So to see that these variables exposed to blueprint, we will need to create a new blueprint based on our first class, first actor C++ here. Okay, let before to compile. Okay, let's compile it first. No, and here. So this is our first actor. We need to make a class. Sorry, blueprint in the content browser. We go to find this actor C++. Right click on it and create the C++. Create a blueprint class based of this actor, first actor. Okay, let's do it and create new first actor in the content browser. Yeah, okay, let's first create that. Okay, so this is my first actor blueprint, and let's rename it as a first actor BP, and I'm going to create new folder, blueprints, and in the content browser I'm going to grab this and send to blueprint, move here. So if I go right now here, and that will be exist there. So as you see now, we didn't compile inside the Unreal, this one. We need to use the live compilers. So there's an error definitely that is related to our variables. View property in actor edit anywhere. Yeah, sorry about that. Okay. And new first. Go ahead and done again. Compiling change for live coding, compiling changes for live coding. The reason I'm sharing this process because I like to feel everything live. Anything happens to me, it better happens to you. Understand how much blueprint is handling this developing easier than C++ Visual Studio. That's it. Maybe my computer is slow, but I don't think so. But let's see. Sometimes doing fast, sometimes doing not. Nice. So let's continue here in our actor blueprint. So right now see our actor lifetime, because that's visible anywhere. An actor level was editable. For example, we can put here 10. We can edit that. But let's see how we can see in the right now. We need to add this one, this blueprint inside the scene in the details panel. We can see, so we can see the both attribute we created. UProperties macros variables is kind of attribute, making the attribute. UProperties creating the attribute. So right now the first one was only visible and just we can see. So let me play first. Install it. See, yeah, when we playing that right now, our actor lifetime adding bar delta time, because in our C++ we added here in the, for example, delta time, adding each time on the actor lifetime. For example, if this is 0, in the 0 will be 0, in the 1 will be 1, and in the 2 1 plus 2, okay, and that will continue. So visible anywhere, the property is visible in the detail panel for the default blueprint as well as in the detail panel for instance of the actor in the level. It is not editable in either case. Visible default only. The property is visible in the detail panel for the default blueprints, but not in the details panel for instance of the actor in the level. It is not editable. Visible instance only. The property only visible in the detail panel for an instance in the level. It cannot be edited. Edit anywhere. The property is visible and editable in the detail panel, both in the default blueprint and in the details panel for instance in the level. Edit instance only. The property is visible and editable in the detail panel for instance in the level, but it is not visible in the detail panel in the default blueprint. Edit default only. The property is visible and editable in the detail panel in the default blueprint, but it is not visible or editable for instance in the level. So let's add for our UProperty life visible anywhere blueprint read only, and next let's make a category equal kind of text, malice dummy attributes, but because it's here named specifiers, okay, specifiers, and the next we can do same here, edit anywhere blueprint read and write and category equal the same. I'm going to grab this and put here and change to int32. About in the tube. We use here int32, a special type which ensures that the integer will be 32 bytes. It is because int type may or may not be exactly 32 bytes, depending on the system on which the game is developed. Okay, so let's compile it. No rebuilding, and let's go here, and where's my... Okay, let's do live coding, compiling. Okay, now we going to open our blueprint. So as you should see, Melis dummy specifier is the category, actor lifetime is kind of read only, and actor level is editable. I'm going to put 0 at the moment. I'm going to in the our event graph. So in the event graph we need to access our variables. Let's see the actor life. Yeah, see, get the actor lifetime we created, and so we can find get let's first compile it, and next we can get our actor level, yeah, actor level. Let's see, set actor level. So right now we can use our event begin play, actor begin play, or I'm going to delete them. Begin play and connect it. Okay. And actor level should here 1. Let's see, right now we put here 1, what will happen? Let's see. Get actor lifetime. Let's see. And play it. And as you see, actor level when beginning the play, it's setting to 1. And this actor lifetime, because in the code we adding the delta time on it. And let's stop them, and actor level 0 of that. Let's start again, begin play, and check that actor play 1, stop, yeah, and come back to default 0. So right now, similar the properties, I'm going to talk about the functions macro. Your function can expose to blueprint in the similar manner to way the variable can be exposed to blueprint. The function macro allows for this. So in this case, in the our class, our first actor header, I'm going to similar this add u function. Okay, U function, and the U function should be blueprint callable only. And next, void it means not have a plan to return. Void check life, check life time, lifetime, check a lifetime, and semicolon again. U function, U function, U function, and this U function should be blueprint only implement in the event graph. So, but able to blueprint callable. So, and next need to use void print something or print our level. Okay, then the function. And right now we have a two function. As you see, for this one brought the green color. It means we need to define this in our CCP because we need to implement in our C++. Let's do that and create definition, and I'm going to use our actor level equal our actor lifetime, and semicolon. Okay, so right now if I compile it, okay, no, and come back our environment, check again, compiling change for live coding. It is interesting to take a while. Okay, so now let's go to event graph. We can access right now that two function. That two function we rename check lifetime. Okay, this is the function of our connection. Let's use the eventic. That eventic will run this function. So then each frame this will be check the lifetime. Let's compile it and play it, and you will see what's happening. And check that our first actor. See, eventic running our actor level, because our actor level was equal eventic. Okay, see, looks similar this, but because we set our actor level for, I guess, integer, because of that we have here float, we have here 32. Okay? 40 for example 42 blah blah, and here 42 just only. Let's stop it, because lifetime because we're using the in the begin play. Okay, in the eventic, right now eventic, because the frame is 0, it's setting to 0. And next we need to print that, isn't it? So we create event here, and next we need to create event print level. Okay, we need to print that one and use the print a string. Now we need to get our actor level variable, actor level variable, and put here and compile it and see. Let's see the now we need to again call it. So here, as you see, our print level gets called, the functionality defined in the event graph will be carried out. We simply need to call the function somewhere. We can call the function from the tick event. So let's do call our print level, okay, print level function, and here. Okay, so if right now compile it, yeah, see, let's check the duration for 0 and play it. 2, 3, 4, 5, 6. This is the frame, and that is so interesting. So we creating the event print level able to implement inside the function. We don't write anything here. We don't define anything about print function, print level function there. And let's put p. And next, as you see here, this event print implement something, but we call it here, okay, as a print level. I think that is clear. I guess right now this is clear. We create the event, we implement inside the event graph, and next this event called by another event tick, and this is running each frame our check lifetime, and that create to us print level. And let's compile it, and next need to talk about the component. In the next video we will talk about the component, okay, how to create component by C++. Thank you.